Okay, I had to start this over again because messenger things. Anyway, this is an update of the problems that we're running into with the current redesign for ExtendTree v2. So I'm summarizing all of the problems and then what we plan to do to fix them. So, current problems. This is with our current implementation, ExtendTree v1. Update ref for cow sucks. It's completely unbounded. Well, it's not completely unbounded, but it's unbounded because we do reference counting for cow-only trees. So like the extent tree or the CSUM tree, all of those blocks are reference counted, and therefore any updates of any extent could potentially update n number of extents, and it just kind of goes from there. So removing the cow-only blocks from the extent tree is super helpful here, but we still have the remaining problem of every time we cow a shared block, we have to push our reference for our root to all of its children. You can have somewhere around 500 children per level, per node level. This doesn't count for level 0 or for the root because that's not shared. So like, a depth of 3 tree, if you cow node or level 1, you're going to push 500 reference updates to the extent tree. This sucks currently because that just sucks a lot, and then you not only get the 500 references, but if they modify a bunch of different extent tree blocks, you could double that easily, so 1,000, and that's like per level. So this is kind of a bummer. Who owns me? To figure out who points at a particular block, you have to do backref lookups. Because we have implied references, that is, we insert a reference for ourselves when we create it. So like block A, subvolume A creates block 4, right? We insert a reference that says block 4 is owned by root A. And if that's a leaf, and then we snapshot, you don't know that level 0 is owned by is referenced by a different snapshot. You have to literally like walk all the way up the tree until you find more references and then like add it up. For deep-ish trees, this ends up being pretty expensive. This is part of why QGroups super duper sucks, because you have to do this all of the time, because you have no idea if the thing about QGroups is you need to know, like, 1 to 0 is fine because you're freeing and that's easy, but like n to 1, this transition is like super important because you need to know to convert shared count to exclusive count. So this sucks. Figuring out, did we go from 1, like 2 references to 1? It's not easy to tell that currently with QGroups, and you have to do full backward, and you can't even guess, right? Like you can go from 2 to 1, and like especially if it was a shared extent, like that shared extent could be pointing at 7,000 roots, and you have no idea because the way we push down references, it's lazy. So like you're only going to see 2 to 1, and so like for every update, those 7, like if you cow that block 7,000 times, every single fucking time we're going to have to do a lookup to see if we have multiple roots. So that sucks. And then this part is delayed refs need to run in the transaction handle. This is kind of, so this is like no shit, Joseph, but but this has kind of like pretty big implications in that because we have fucking 10,000 delayed refs that have to run, they have to run. So if we like do this thing and like fsync and we allocated a block group and thus are forcing an entire transaction commit to go to disk right away, we have to wait for 10,000 fucking things to hit disk before we're allowed to do anything. That super duper sucks. Yeah. Okay. So the solution to this was snapshot trees. Snapshot trees for Q groups. Sort of Q groups. It's two things actually, but it helps Q groups. Because now we record, okay, A was snapshotted at a generation 3 by B, and generation 7 by C, and generation 12 by D, right? So like now we can say for any given block pointer, we can say if its owner is like A and its generation is 1, then we know like that B, C, and D all reference it because it was all, they're all after. At the same point, you can say like owner A gen 13 isn't owned by anybody, or like owner A gen 8 is only owned by A and D, that sort of thing. That's like super, super nice and cool. And then drop trees is to clean it up. So if we cow down from A, drop trees was to solve the update for ref. So update ref for cow becomes insert one item for my root for byte number. This means that every level has one operation, one op per level. It's the thing to say, hey, I don't give a shit about this guy anymore. So if I'm counting down from A, I insert a thing for A, and that needs to be inserted in my drop tree. That's one thing. And so if we count down from all of them, it's like 4 blocks. Like if we modified one file, file A, or file, foo, from A, B, C, and D, in the same transaction, we're going to have 4, have 4 times like height blocks. So like 3, maximum. So like the max is what? So 8. 4 times 8 is 32. Max of 32 blocks if we modify all that. Like that's insane. Like there's no fucking way we'd ever have 32 blocks modified, or 32 items rather for. It could all fit one block, but 32 items per that, like that would be nuts. That would not happen in our current scheme. All right, but there's a problem. There's a kind of a glaring problem. Well, there's a few glaring problems. First is chained. So A into B into C. So like 2 and then 4, right? So A points at like this bullshit. Okay, and then we snapshot at B, but then we modify, this path before we take the snapshot at C. So now C points at this and this, but it points at this instead. So the problem here is that, block 1 right here has a gen of 1. If we did the lookup, it would say, okay, B was snapshotted at 2, and this is 1, so B references it, A references it, and C references it, because B was snapshotted by C at 4, and it totally references me, because 1 is less than 4. But this isn't correct. It's not correct because B no longer referenced this block because it cowed before the snapshot happened. So this is incorrect because of chaining. This is what I mean by chaining, is like we snapshot, it's indirectly shared by another spot. The other problem here is snapshot deletion. Snapshot deletion sucks for this. I don't know why I didn't think of this, but I just fucking didn't. Snapshot deletion essentially makes it so that in order to delete B, we would have to walk every block that B references and insert a drop item for it, for everything to like work out correctly in our current scheme. This is not optimal, we'll say. It's not good, right? The the kind of solution, not solution, but like the thought you might have is like, why not just fucking delete this guy? Be and delete anything that he directly points at. Because if you delete this guy, you lose that there's this connection, right? You lose this information. So you have to leave this snapshot entry until we completely remove everything that it could have possibly referenced. The other thing is like now we're kind of, the other option is like, well, don't fucking do that, dude. Just like do things that you care about and leave everything else and let it figure it out. Again, the kind of problem here is now that we now have like a problem here where, say I free this guy on both of these, it's only got drop entries for A and C. It doesn't have it for B, and so it doesn't fucking know that it can be freed. So what the fuck do we do about this? It's not easy, right? We basically have to post process and basically be like, okay, well, this guy, his count is 2, but it's really 3 because there's an implied drop reference. But like even this guy will have 3 because he was dropped by B. And so we can't even be like, oh, there's this implied reference, because then we'll be like, this is drop count is 4, but its maximum reference is 3. What the fuck is going on here? The same goes for like Q groups. Q groups has this similar problem because it's the same problem as it's the same problem as free, because again, we have an improper knowledge. We think that this guy is referred to by 3 things, but in fact is only referred to by 1 thing, and so we don't actually know to do things. And actually, it's kind of okay. It's sort of okay, because when this happened, we would have changed A to exclusive. So it's not actually that bad, but anyway, it's more of a problem with free. So this is solvable, because what we can do is, if we're processing block 1, we can say oh, B deleted us at 3, right? And so like this link is broken, and so it doesn't count. And so like its real count is 2. So if A cows down and it drops it, it knows, okay, its real count is 2 and this is 1, or this would be 2, and we're done. Right. But this is kind of it's not an expensive operation. It is way cheaper than anything we currently do, but it is more complex. The final kind of kick in the nuts here is where's my it's this button. Data. Data kind of kicks us in the nuts here. My original plan was to continue to use the drop trees for the same thing, but then I forgot about clone. So say we have a leaf here and we have an inode with nothing but cloned file extent. Say somebody decided to be an asshole and we allocated this chunk, and then we just cloned him over and over and over again into our file, just over and over again, because we suck. Now we have extent references for so we'll have like, say this is byte number like 4K, right? So we'll have 4K root, say this is root A, I know 1, I know that's not possible, but whatever. So we have 4K owned by root A, I know 1 offset 0. And then root a I know 1 offset 4k, and so on and so forth, all the way down. So we have like, what, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 references. Now, we fucking snapshot A into B, and then we go down to A and we remove this whole fucking file. What do we insert into the drop tree? Well, we are dropping every single one of these operations, right? But the drop tree is going to be based, is like, byte number offsets. We can't like encode all of this into a key. Well, we could, but that's a different story. But byte number offset into the key. So we have to like stuff all of this information into an item, which is okay. But we want to say like, okay, we have this like giant fucking item with all of this information, and then we have to say A dropped. And then what happens, like, since this is the same, we're going to have like A dropped for, offset, like all of this information, all that information up there. And then we're going to do it again. Because again, these are all unique. Each one of these is a unique reference in the extent tree. And so like we need to make sure that B drops this guy before we drop this reference in the extent tree. And so we're going to have this like duplicate byte number offset because it's the same all the way across. So in order to tell if I've inserted my guy, I'm going to have to read this whole item. If it's not right, I'm going to have to go to the next item. And if it's not right, I'm going to have to go to the next item. Now, say I did this, a million times because I super suck. We're going to have to linear search to find if we even need to insert. Like we may have to insert, and like then inserting is going to super duper suck. So this is a problem. This is actually a kind of a huge problem. The solution to this is unpleasant. So the solution to this is btrfs fs inc ref at level 0 only. No other solution here is as painless as this is. So we are going to have to, in this example, right, where we have, clone all the fucking way down, we're going to have to do this super annoying thing where we insert a extent reference for each one of these things for our shared block. So now we only have to do this we only do this on do this for the owner. We're only doing this for the owner because we don't want to have to like say that we did it or not, right? So we don't want to like say it's owned by A and we come down from B. We don't actually want to fucking do this because then we have to like write something to flag that it's already been done to make sure that nobody ever does it again. So we're going to leave this for an operation that only the owner can do. So when we do the drop entry when we find this guy, we have to schedule a cow and like update ref for cow for this guy. And this is going to push into the extent tree a shared ref from, byte number, whatever the leaf, byte number of the leaf. Byte number of the leaf. Okay? And then what we will do is later on, when we free the byte number, we see that level is 0, and we go and do the dec ref for all of these blocks. So dec ref all blocks or all file extents, and then and then we're done, right? At that point, it would free everything up. Any references that still existed would go away, and we're good to go. But again, now we're better than we were originally, yes, but we're still having to do this like update ref for cow thing in the transaction. Several hundred, like we won't have 500. I think the maximum file extents that we can have in a leaf is like 210 or some shit. But 210 is still not awesome. These are all bummers, right? We're getting a lot for snapshot trees and drop trees, but we're kind of giving up a lot too. We're giving up kind of simplicity and freeing. We can still find who owns what with queue groups in a cleanish way, but it's not straightforward, right? It's still not easy. It's way less expensive. It's significantly less expensive, but it's not easy. So enter something that's gonna make Zygo really fucking happy, and what Chris has been trying to get done forever, which is garbage collection. So I am not a fan of garbage collection ever, really. The big problems with garbage collection is enospace, right? At some point, in some case, we will have to pause writing to the file system to allow garbage collection to catch up. That's not great, right? That's not an awesome thing. That being said, with our changes, we're going to be able to like drastically reduce the amount of metadata that we hold out. So this should hopefully not be a big of a deal, but hopefully not be a big of a deal is a thing that I will be cursing myself for saying in 10 years. It's not great with enospace, but that's essentially it. With the garbage collection, it allows us to do a few things it allows us to solve a few problems that we've had forever, and that is no more delayed refs holding the transaction. So right now the delayed operations of like inserting the drop entries for like this sort of thing, that has to happen. That's going to happen in the transaction handle, but because it's so small, it doesn't really matter. Unfortunately, there was still the case of like, in the normal case, what we would do is we would say like, okay, drop count equals max ref free extent, right? So the free extent part would still have to occur in this, transaction handle. That's not that big of a deal, honestly, for metadata, but it's kind of a big deal for data. If you free a 128 meg extent, you're now having to release, thousands of checksums. Releasing thousands of checksums is kind of, we'll say intensive, and this can not stall out, but like add latency in the transaction commit. So we would like to theoretically let that operation take longer than it does. The other thing is these cases over here, this chaining thing, this is a little bit more expensive, and we don't necessarily want to hold up a transaction commit while we try and figure this out. Because like if we have to do this like a bunch, if we have to make this calculation a whole bunch, like it's going to super hurt the transaction commit. And then this thing right here, the inc.ref thing. I don't want to do Btrfs inc.ref in the transaction. I don't want to be forced to do this in the transaction handle. I don't want to be forced to add 210 references to the extent tree in a single transaction. I want to be able to commit the transaction at any point. Enter garbage collection. Garbage collection allows us to delay expensive operations. So instead of now like what drop count equals next, I can't even read my own handwriting, so I wrote the wrong thing. Max reference. Instead of saying, okay, now we have to go do this operation, we insert a free operation into the GC root. Then we process the GC root separately, and we process it one item at a time, and as we clean things up, we modify it in the transaction, we end our trans handle, and we go again. So that means that like if we're freeing an extent, for example, and we need to free checksums, we like start a trans handle, we free a checksum, and then we end the trans handle. And we start a trans handle, we free a checksum, we end a trans handle. We do this over and over and over and over again. And this means that this means a few things, like again, enospace, like we don't actually free up the space until all this bullshit is done. So it means like freeing is going to be a lot longer, but it also means it doesn't impact the transaction commit. We still can only pack so many changes into a transaction handle, and when we stop, we just stop. We're not forced to wait for any particular thing to happen. It all just kind of, we just say, all right, everybody stop, write our transaction, and keep going. And there's no like flush delayed refs that has to, we have to flush the drop items and any like GC items that have to go in, but process it, like these big long processing things no longer hold up the transaction. The other thing that we would do is this means that we're going to add like free extent. In a lot of cases, like we're going to have free extent may not do anything. So remember all these like terrible cases over here where I was like, okay, well, we don't know who's pointing at us, right? So now what we can do is we can like for example, drop snapshot is we can say, okay, this guy's deleted. And then if we go to free this guy over here, his count will only be 1. And we say that like, oh shit, we found a deleted snapshot on our thing. This guy could really be free. Schedule him for a free extent. And the free extent thing then goes and like actually figures out like who really points at us. Excuse me. By doing the more complicated math. And if it turns out like, in this case, C would still point at us. Like we do the thing and we check and we say, okay, we don't have a drop reference from B, but B is gone, so B doesn't exist. However, it's less than 4, and therefore C points at us, okay, don't free anything, bail. And we can kind of do things, interesting things here by like updating the drop reference, thing with like maximum, like what our maximum count is. So we can cache the information to like avoid doing a free later on, if we wanted to. Yeah. This is not what I like. this is not as clean as garbage collection is not as clean as like our previous thing. Our previous extent, reference count, everything is nice and clean. It fits into the brain really easily. This is ugly, but its ugliness gives us a real benefit in that we're no longer forced to make updates to global trees in the same transaction. The only things that we're forced to update are, the drop entries and any garbage collection events. Like those have to go in, but those are going to be significantly less in volume than the ink ref. Like the ink ref will have to be done. But like again, the ink ref, we can simply ink ref as we go along and save the state in the GC. So it doesn't have to all happen. Like simply the hey, I need to ink ref option goes into the GC tree. Yeah, that's the plan currently. I'm going to start implementing it and see where this kind of bites us. I'm open to suggestions for better ideas. Thanks.